So I'm Shubham Srivastava, working here at a GeekyAnts as a tech lead in ML and AI domain. So I'm working with the, let's say, AI agents, building a RAG system, then conversational AI with the voice feature and all. So as we have to discuss AI agents, so like nowadays AI agents are the popular, like one of the trending topic here. So when anything comes to tech, there are a lot of things like architecture, design patterns, and there are drawbacks are coming. So to discover the AI agent architecture and design pattern, we'll discuss first uh, what we'll cover today. So we'll a little know about the what is AI agent, then their architecture, design pattern, and then we'll move to the Q&A and yeah. So yeah, AI agent. So what AI agent like? AI agent is basically a smart software. It's not a LLM or it's not a model. It's a software which making a smart decisions or actions based through help of the LLM only. So LLM is like a brain for it, and the software is acting smartly with the help of tools, function calling. Yeah. So they're like model like GPT and Claude. So which are like capability to define okay, uh, when the tool need to be called and what tool need to be called. And tool is simply a function, a program which capability to perform any task doing coding or merging code, uh, etc. Yeah. So coming to the architecture part, so there are major component in a agent are tool, memory, LLM, and then prompt. So prompt is a basically persona of the agent. So it's define how agent works, what are the communication styles and all. Tools are the basically functions which LLM can execute with the help of uh, uh, software, and let's say memory is context window. Let's say if we are talking something with LLM, so LLM has a limited context window and all, so we can put all everything like knowledge base, a book, or some a rule kind of thing here itself in a memory. Coming to the design pattern, so there are four major design pattern in a AI agent. So one is reflection, another is tool call, then planning, then multi-agent collaboration. I'll discuss this in a next slide in a bit more detail. So design reflection. What reflection is? Reflection is basically there are two LLMs who are performing tasks together. One is let's say doing coding, another is doing analysis over their coding and provide feedback on that. So let's say if we ask to code something, then that agent will LLM will code it and provide to another LLM, where that LLM analyze those code and then provide a feedback to first LLM. And this iteration goes on. We can configure that within n number of iteration, and then using that we'll get the refined code. So without human intervention, it will refine automatically. So I'll show you one of the example. So I asked to write a program to some n digit, so it's come up with the first version. Then the another LM is providing feedback on it, and then it's come up with the latest version. So here you see it's handle all the error and all automatically, so we don't have to prompt it again. So final output we get a refined version of it. So this is one of the design pattern which we can use. Let's say take a coding. So as a cursor, so let's say if it's doing some mistake in a coding, let's say importing library or installing something, so it automatically get feedback from LLM itself. Okay, this library is imported not correctly, or this dependency are missing. So it will automatically reiterate again and automatically update the code base without any human intervention. So let's say if we are relying totally on LLM, we might get little less uh, quality of code. But again, when we are trading with another LLM, which have we have prompted to provide some analysis, so it look over the code and provide some feedback to another first LLM, and then it will refine according to the feedback itself. First LLM is let's say personalized to code. So we define okay, system prompt is there. We defined okay, you have to code it, and the second agent which have a prompt, you have to analyze the provided code. So then we are provided prompt to a code to let's say to some n number of digits. It goes to first LLM or first agent. It will provide a code base to us. Then again, let's say we got the output from first LLM, and then we'll put to the next LLM with the same output and prompt. So it will analyze the output of the first LLM, and then it will provide a feedback, generate a feedback for first LLM, and then again in the same iteration will voice those feedback to the first LLM, and then will let's say the first LLM will improve it. So now moving to the other part. So here, like if you see, like we have like I have developed like I have put it a iteration kind of thing there, like a drop down. Now moving to the next design pattern, tool call. So one of the major development in like LLM is now LLM is like able to decide when to call which functions. And functions are like probably like we can define, okay, like we need to get a weather, or we need to fetch our calendar, or we need to schedule event. So these are like simple unit functions. These are defined like purely based on a parameter, and LLM can decide which function need to be called when based on our interactions. So this help us like not to like go into the rack system, like where like our software is deciding which function is called to when based on certain query parameter and all. uh, Now LLM is now more intelligent to decide which functions need to be called when. So for this, I have like a demo. I'll show in the end of the call with the code base. And next one is like planning. When coming to the tool call, so there is like something missing with the tool call is like LLM is lagging on a planning part. Planning is like what need to be done in a subtask. Let's say I have provided some task to it. Now the planning it goes to the one LLM with the some prompt, and it cut it down into the some sub task, and then further break down it into the steps and all. And based on the task, it will handle all the calls. Let's say if it need to call another LLM, or it need to call some tools, or it need to call some APIs, and yeah. So this is like one LLM is planning and then executing his tasks. And one of the like research paper which I got from Hugging Face, they have developed like a LLM where like they have provided some task like, okay, you need to generate an image of a girl with a reference image, and like then after you need to describe the image with a voice. So here, like that planning is decide, okay, these are the steps need to be taken, and then the second stage will be model selection, which model need to be selected, and it will get pulled from Hugging Face itself. Then it's start executing the third LLM is start executing the task. Okay, these are the tasks which need to be executed, and then fourth is like to formatting the response into the let's say output format. The persona is defined in such a way of the planning agent, so it will like like plan it out. Like if you provide a small query also, it will plan it if needed only. So it will act smartly. So let's say if provided some tasks which have like let's say set of steps, then it break down into the set of steps and then execute it. So in normal prompt, let's say if you provide a prompt to LLM, it will generally provide a output to you. So like we can put the human in loop itself. So let's say if we are doing some critical task, and we have like some critical actions which defining the tools, so we can put simply a human in loop kind of like where like we got the output from LLM, and then now we are saying, okay, send a notification to user if you willing to take this action or not. So if human take that action, like as we doing in a cursor, if you like familiar with the cursor, they before deleting any file, they are like prompting a user click on run command. So now next, like the last one is like multi agent, like where like now let's say define a generic agent. We came to like multi agent kind of design pattern where we are designing like small agents where the agent are like expertise of doing one task with a set of tools and memory. And now like if we provide a like task to that like chain itself, it will execute in a chain manner, like okay, we'll go to the like design team, or we'll go to the coding team, then we'll go to the testing, then we'll documentation. And like in in there, like say we have multiple like entity itself. So these agents are like this entity are itself a agent. So they are doing their task based on the query, and then they are providing task either to the next agent, or like it's to the next team itself, a flow. So here, like we can design small agents itself with a tool, with a memory and LLM, and they can perform their task. So this will bring like a refined output to end user. So these are like these are ideal one. So like if like let's say cursor is one of the tool which are like using the concept of this one, like where they have like multiple tools and all, and they're calling based on what is required. So probably we are heading toward this, but not 100%. Yeah. Yeah. No, so it can be distributed, but in a multi-agent in environment itself. Yeah. So in the planning, there is only one agent, which is which is planning itself and then executing their task with the help of either another LLM call or with the help of tool calling. Yeah, correct. Agent is a piece of software, and on top of it, like another agent, planning agent, who got the task. Like let's say we have to build a software. Now it will break down into the subtask, and it will assign to corresponding agent itself. And agent will deliver their task and provide feedback to the planning agent. And planning agent might get merge all the output to a single one, and then like provide output the end user itself. So these are the references where I referred. One of the a research paper is there. Like this is from Hugging Face itself. So now moving to the demo part, like I prepared a demo for like calendar agent. So where like agent is able to like analyze my calendar and plan it out my let's say task or like suggest me best time slot and all. So let's say if I say hi, so it's saying it's a generic output of LLM. But let's say if I say, so now you see like agent is making function call to update their memory, and it's saying like username is Shubham, and it's asking for me like to approve it also. So if I'll approve it or like I disagree or I want to edit, I can do it here only. So let's say if I'll continue with the S, yeah. So it updated memory and now it's have a context of my name also. So it will call like simply calendar API and then it will like get the plan. Okay, these are the available slot for me, and then again let's say once it's called it will provide the slots, then it will like ask me to schedule a task, like schedule a meet with the agenda and like with the attendee and also. And once I'll provide the attendees, it will automatically like push it to the calendar itself. So like coming to the coding part, so these are the function like to get the calendar event, and then this is a like function to get to create the calendar event, which is like purely like API call only, which is doing Google API calls. And then we have like a prompt, like let's say system prompt where like asking AI agent to manage the memory and integrate with the Google Calendar itself. Then we are providing like in OpenAI, so they have like system prompt. Then like there is a memory prompt itself, like where we are dumping all the memory. We can do it efficiently also. And here we are providing the configuration of tools. So here we are like these are the tools in tool list where we have like a let's say tool name, then what description of the tool, then their parameters, and then their descriptions and all. Simply with the like other functions also. And then we are simply just calling the LLM with like that OpenAI API with the input itself, and then it's generating. Okay, these are the like AI responses, and if any tool need to be called, the OpenAI is sending the response in a tool call itself. So based on that, our software decide, okay, it will output in a JSON format. Okay, these function need to be called with this parameter, and that parameter have actual values. So once we'll like get the tool calls and we'll decide, okay, we need to like call this function based on a function name, and then we'll need to like pass the argument. And then let's say here, yeah, let's say there are two kind of create event, like event where like we need to update the memory and like calendar event create. So where we are putting a human in loop, like before, like we are asking for user confirmation. Like okay, you need to confirm this action or not. Based on the confirmation, we are like proceeding with the further. Let's say here. So we are like executing. Let's say we are executing each functions with like if and else block. Like if this function is called from OpenAI, then we'll call memory update. Then we'll call calendar list, and further once we'll get output, we are appending it into the history itself of the let's say OpenAI like message history. Then once like we'll get the output of the function call, we'll simply calling the for final response, and this loop like goes on like until we'll exit it. So I've taken the help of LLM. Even like I have taken the help of like a cursor only. So cursor have like a bunch of like good tools. It's a, like simply they're calling like same only. So they're like there is system prompt, there is a user prompt, and there is like let's say tool calls. So like system prompt is defining the persona of that like LLM itself. So now LLM will decide which function need to be called. Now our software is executing that function only. It's not like OpenAI is executing that function. We are only executing that function. But now OpenAI is like let's say OpenAI LLM making a smart decision which function need to be called when based on our interaction. The function is like a function is predefined. So the unit functions, like let's say create calendar event or list calendar event, are predefined, which are like meant to like provide the list of all events, and one is to like to create an event. Now, like based on our interaction, LLM will decide which function need to be called with what certain of parameter. Let's say start date, end date. Then like here we have like summary, description, and attendees also. So like it depend on like context window itself, like what the context window they are providing. Like let's say token kind of like let's say to every LLM model have a token limit. So we can provide the certain limit of like function or like tool calls there based on token limit itself.